Okay, it's getting exciting. 63 viewers. Can we get to 100 before we get kicked off? Triple figures. Come on, we can do it. We can do it. Feel free to hit that like button and share on social. Last chance. We will kick off in just a few minutes now. Alright, 1 minute to go. We're at 80 viewers, 20 to go to 100. We're almost there. Alright then, thank you everyone for joining today. Let's get this party started. Hopefully you can all hear me. Feel free to say yes in the YouTube live chat if you can hear me okay. Cool, okay. So welcome to the first ever TensorFlow.js community show and tell. We finally did it. I know it's been quite some time in the making. I think I've been talking to many of you over the past month on Twitter, LinkedIn, and all the various social channels. And you're all coming from very different time zones as well. In fact, today we have people from San Francisco to Tokyo and pretty much everything in between. So a massive thank you for all of you for joining today, especially those of you over in Asia where I believe it's around midnight or even 3 AM in Tokyo. So thank you once again. Now, my name is Jason Mays. I'm going to be your host today. Essentially, I am a developer advocate for TensorFlow.js here at Google, which basically means if you're using TensorFlow.js anywhere out in the wild, there's a good chance I'm magically going to appear at some point, especially if you're using the Made with TFJS hashtag on Twitter or LinkedIn. Now, if you enjoyed today's session and you want me to do even more of these in the future, please do let me know, as this is the first time that we're actually ever doing this. For those of you who are joining in on the live stream on the Hangout, who are presenting, just feel free to mute the YouTube live stream, otherwise you're going to hear an echo. Cool. Now, as a developer advocate, my job is to make community gatherings like this, but this is just one of the things I could be doing, such as coding more prototypes for you guys, presenting at conferences, or writing up case studies, or so on and so forth. Essentially, I work directly with the product team, and I try and put myself in your shoes, coding alongside you in the trenches, using always publicly available resources to make sure it's a good developer experience, and it's as good as it can be. And if it's not, I'll try and make the resources to make sure that it is. So I'd love to hear your feedback and let me know if there's anything that you feel is missing. Now, I personally would love to see more of these show and tell sessions, and I'm really inspired to see 85, almost 100 of you joining for the first one ever. That's really great, with very little promotion on my side, so thank you very much. Now, with me today, I have 8 wonderful presenters who hopefully you can see in the live stream right now. I'm just going to go through everyone. Feel free to wave whilst I'm going through you. Grant, Junya, Lizzie, Manish, Max, Jimmy, right? I think there's Jimmy over there, but I see a different name at the bottom there. Rogerio, and of course, myself. So thank you all for joining. And 1 second. Cool. So yes, yeah, exactly. But trying to take their first steps of machine learning. And some of you may even be new to both, and this is completely fine. In fact, this first show and tell will be aimed at enabling beginners to get inspired and take their first steps as well. So to ensure everyone has some context for what we're about to dive into, I'm very briefly going to cover what TensorFlow is and why doing TensorFlow in JavaScript is actually a super cool thing to do. So let's get started here. First of all, what on earth is TensorFlow? Essentially, it's a machine learning library that was open sourced by Google just before the beginning of 2016. And this library contained all the low-level building blocks a machine learning engineer may need to create new models from scratch for pretty much any use case they could dream up. Now, the one drawback here is that at this point, it was only available with Python bindings. So in 2017, Deeplearn.js was born, which was created by Nikhil and Daniel from my team, who rewrote all of this to work in JavaScript. Now, the really cool thing here is that it leveraged WebGL to get the performance needed to power the machine learning. And WebGL was originally intended for 3D graphics in the web browser, but here they're actually using it, instead of graphics, to do mathematics, which is a really super cool thing to do. This also means that it can run on any graphics card that supports WebGL and not just NVIDIA ones, which is typically the use case with machine learning libraries or our Python-based implementation of TensorFlow. So then in 2018, TensorFlow.js was launched, providing the Layers API that made it even easier to use with high-level building blocks. Now, for those of you who are familiar with Keras in Python, this essentially replicated that environment, but in JavaScript. So if you're used to Keras, you'll have no trouble using the Layers API. And for those of you who have never heard of these terms before, no need to worry. There's no need to know about these things unless you plan to use Python. And people in this chat probably are going to start with JavaScript anyway, so no need to worry about those terms I just spoke about. All right, so we know what TensorFlow is, but why is machine learning in JavaScript worth your time? That's a great question, and basically, first up, JavaScript is the only language that can really run pretty much anywhere. Right now, it can run in the web browser as we discussed, on the back end, on the server side with Node.js. It can run in native apps with React Native, which we now support, desktop apps with Electron, Internet of Things like a Raspberry Pi via Node, and basically anywhere JavaScript can run, we can run TensorFlow.js. Now, if we just focus on machine learning in the web browser for a second, as many of our demos today will be in this environment, you're going to get 4 further superpowers. Now, the first one is privacy. By performing all the predictions in the web browser directly without sending the data to a third-party server, the user's privacy is maintained. Now, this is particularly important for certain types of applications where it might be a requirement to do this, such as the healthcare industry or legal. And also in current times, privacy is top of everyone's mind, so it's great to get this benefit for free. The second is speed. Latency is reduced because we're directly connected to the sensors like the webcam, the microphone, accelerometers, which we can access in JavaScript on the client side. There's no need to send that data to the server for processing. And linked to that, of course, you get a cost benefit. Because there's no server involved to do the inference, we don't need to keep a machine learning server running 24/7. So this reduces server costs. All you need to pay for is the hosting of the website and the assets, and the rest will work offline after the initial page load. And then the final point here is reach and scale. Anyone with a computer can simply click a link in the web browser and use machine learning with zero friction. Now, not everyone can install Linux, the CUDA drivers and the dependencies you need to get a server-side environment running, so you can reach a lot more people via the web. So on that point, TF.js could be a great way for researchers to get real-world usage from millions of people to discover potential biases or bugs that may go overlooked in a small team in the lab. Now, many of the demos today make use of the pre-trained models that we have open sourced on our website, such as the ones that are at the bottom of this slide. We've got models for object detection, body segmentation, audio detection, and much, much more in super easy to use JavaScript classes that mean even if you have zero machine learning knowledge, you can gain these superpowers in your application. So I'm going to head back to the presenters now, and we're going to start the show and tell portion of this hangout, which is of course everyone's been waiting for. First up is Max, who's created an awesome website called Shader Booth. And I'll hand over to him to tell you more about what he's created. Over to you, Max.
It's nice to have like a global event like this online when everybody's stuck at home. So I hope that this is at least interesting. I want to talk to you today. Oh, I should share my screen. Okay. So the name Shader Booth. I was kind of thinking, have you ever used like the Photo Booth app on a Mac? It's like a webcam application that gives you a bunch of extra filters you can apply to make yourself look black and white or X-ray, or your face is all contorted. And it's kind of old school, but I always really enjoyed playing with it. I think it's a really charming, weird use of computers. And then the first part of the name shader, shaders are kind of like this image processing technique that I really enjoy. And I'll talk about those a little bit more later, but I think that shaders get a kind of a bad rap of being hard to get started with. And so I wanted to make tools online that make it easier to write fun shaders and have them mutate your face or something like that. So I wanted to point out kind of a few of the things that were swirling in my mind when I was thinking about this project, kind of what my inspirations were. And so the first thing is that if you use Instagram has some really amazing face filters right now. And like there's a whole ecosystem. You can make your own and upload them. But they're all made through this tool that's called Spark AR Studio. And it's completely proprietary. I don't believe you can export your shaders or your filters for any use besides posting them on Instagram. And then you don't really have control over them. and kind of like, in my opinion, you're kind of just you're enriching, like Facebook is selling ads off of your artwork, and it's kind of it's not like the most open artistic community that I would want it to be. And so I was kind of bummed that I like these effects and I wanted to make my own, but there's not a good platform to do so without signing all your rights away and not having control over the output. And so I had, in the past, I had tried, like in JavaScript, different facial detection libraries. This is one called CLM Tracker. It's pretty good. You can see right now that it gets my face most of the time. The fact that I have glasses on, it kind of that's one thing that messes it up. And this is using kind of previous state-of-the-art face tracking technology, but it's not perfect and doesn't work on everybody's face equally well. And so I've made demos with this in the past, and then I showed it to my friend, and it didn't match their face or something like that, and they were kind of disappointed. So I saw that recently, this blog post from the TensorFlow blog post from TensorFlow blog that they were open sourcing 2 new models that and packaging them nicely for TensorFlow.js. And these were like this hand pose and this face mesh. And kind of like the first thing I do when I see a demo like this is that I just want to play with the example and see, because that's there's no substitute for kind of seeing how well it works and how fast it runs. One thing to note here is that because TensorFlow is quite flexible, there's you can change which backend these models are running in, and so yeah, I guess it's not really important. But the thing is that there is some flexibility where a model can be created and you can consume it in different ways depending on what your needs are. And so as soon as I saw this demo and saw how closely it was matching my face, and the fact that it gets my mouth quite well, I was really excited and I definitely wanted to try it out.
Just a quick thing for the people viewing right now, just to say that the demo you just saw, it might look a bit janky on the live stream, but it works buttery smooth if you try it in the web browser, right? On your side, it's working smoothly.
Oh yeah, totally. I'm sure that I don't have great upload frame rate. Sorry, everybody. But one more thing that I think it's important to mention is that they've released along with this model some. It's almost like a ingredients list, because with any machine learning, it's kind of like a processed package that you are consuming, and it's good to look at what the ingredients are and what the goals were. So they're actually saying that this was designed to be. It was trained on camera phone, like front-facing cameras. So it kind of it's meant to be run on data that's similar to what I want to use it for. And they also mentioned that their training data includes like people from all over the world. And this is really important because if you are doing any kind of machine learning and you're using a model that's trained on not a wide enough group of people, your results are not going to be good, and you're not going to know it if it works on you. And so I'm glad that they published this data, and it made me feel more confident that I was making something that was robust. And so definitely, yeah, if you're using some kind of model that someone else trained, make sure that you do a little research into what they trained it on, because that'll tell you how it might perform.
That's really cool to see. Thanks for that advice there.
Totally. And so I'll give, this is what shader booth looks like. And so the main screen is that you have this, kind of the output, and overlaid, the contrast is not great. And so maybe it's hard to see if the stream is low quality, but I have kind of this code on the left. And this code is the code that represents what the shader is. And it's basically an equation that runs for each pixel and comes up with the color value by mixing other ingredients. And so I like to just show people the hello world of a shader is you just say like output red. This is like the simplest shader, and it's just saying that every pixel is running this program, and every pixel the output is always hard-coded to red. And so that's the simple shader. And this more complex shader is kind of it's a few if statements that's deciding if I'm inside the face, mix the camera color with some blue. If I'm near the lips, mix the camera color with some red, that kind of thing. And so this is the basic equation that you can edit. And with those parameters, you can write an equation that does some really interesting things. And so my favorite one, because Shader Booth was designed so that you can use it as an editor and then share your filters. Some people have been writing their own shaders, and so one from Ricky Ruser that I really like is this. It uses this God rays utility function, and so it
This is
looks like
definitely
this
super
really
cool.
cool 3D effect. The thing is that there's a little bit of trickery here. This is kind of a 2D effect. The way that the eyes and the mouth spread out are almost like it's almost like a blur more than, and so it looks really cool in 3D, but you can get by with a lot with graphics. Everything is always about kind of smoke and mirrors.
So essentially, just for clarity on my side here, so we're using face mesh to detect where the key landmarks on the face are, and then you're using the WebGL code to attach to those key points, like the eyes and the mouth, and then in real time shining light from that perspective. Is that correct? Or is that wrong?
Kind of. It's just that what I'm passing into the shader code is that face mesh gives me this. I'm using face mesh to get the data that you see in blue here.
I see. Yeah.
And I'm passing that as a 2D image into the WebGL. And so the WebGL is just kind of doing 2D image processing techniques on this basic data in order to augment the camera stream with more stuff. And so it seems limited, but it's actually, you can, with some extra math trickery, you can get away with some really cool effects. And I think probably the best way to learn is that if you do flip through some of these examples, you can try changing some of the numbers and
nice.
And that way, you can see what effect they have. And so
perfect. So for those who are tuning in right now, I guess go play with the numbers and tweak things and see how it changes stuff and get a feel for it, I guess, right?
Yeah, definitely. And if you are really curious about shaders, there's a really great resource called the Book of Shaders. It's like an online tutorial that kind of walks you through how to wrap your mind around them and different cool examples.
Awesome.
And
Nice.
so I was just really happy that when I tried out this face mesh model, that it was performant, and I had a little bit of tuning over the trade-offs of accuracy versus speed, and then I could throw that data into the blender with some other techniques that I was already excited about, and kind of make something that works quite well on a lot of computers. And I benefit from the work that other people do to improve this model in the future. And the last thing is just that it works quite well on phones. And so it's cool to see. I've always been frustrated with I love the web platform, but it can be, some things have been hard to run performantly, like very intense calculations. And it's nice to see people pushing on the boundaries and making things that can be shared really easily.
Because I remember the old days where things were very laggy, and nowadays with the WebGL acceleration and all this kind of stuff, on the machine learning side especially, we can now get the buttery smooth 60 frames a second or close to it, at least on a modern computer, which is great.
Yeah, and just because it's on the web, I have access to, I can make links to generate these. And so if you write a shader, you can generate the link and send it to anyone, and they don't need to install anything. And so that's a power that the web has that's really great. And so, yeah, I think that's all of the main things I wanted to cover. If you're really curious, you can check out the Shader Booth GitHub. The most interesting files to look at.
Perfect. Well, thank you. Thanks for listening to me. Thank you very much. And if anyone has questions for Max, whilst he is available in the live chat, you can often ping that in the live chat as well. And we'll move on to our next presenter in the meantime. So thank you very much, Max. Thank you. So next up, we have Junya, who is coming in all the way from Tokyo, I believe, and he's going to talk about how he has recreated face mesh in Scratch to teach children in his coder dojos. Over to Junya.
Scratch is a graphical programming language developed by MIT. Let me share my screen. Switch to, as you see, you can switch the language like this, and I will select English. From today, I will show the extension that I created. You can use the machine learning on the Scratch. Scratch is because of its simplicity. It is very popular among kids, and but not only kids. Anyone can easily program using Scratch. And at the same time, it is very powerful because developers can extend their features by creating extension using JavaScript. The extension system is it's like a plugin system. I created several extensions using TensorFlow.js and added machine learning features to Scratch. So let me show. I will add the extension from here. You see there are many extensions. This is a customized Scratch. The source code of the Scratch is on GitHub, and I customized it to add my extension, and it's published, so anyone can use it. If you are interested, you can access this extension from this URL. And I will add ML to Scratch here. The idea is it's the same as the Google Teachable Machine here. You can easily create machine learning models here, but also from here, it's using TensorFlow.js, and awesome. It's quite same idea. You can teach the machine by showing the webcam images and labeling them. So first, let me show the example by clicking the block here. I can train. I can teach the machine that this is number one. I will teach the neutral.
It's great to have everything in a drag and drop fashion, which is, I guess, kids love this kind of stuff, right?
Yeah, it's very easy. And I will click. The first time it takes a while, but I will continue. Yeah, you see, good. Every time I click, this is the counts of images. I will teach the machine. This is like neutral images, like 10, about 20 images. Okay. The next second, I will raise my right hand, and I will teach the machine that this is number 2.
I see.
And I keep going to give several images. And next, I will raise my left hand. I will teach that this is number 3. So I keep clicking like this. And if you check, yeah, here, this is the label right now. And the machine already recognized that this is number
the right
3.
class. Yeah,
yeah,
nice.
Yeah, right now it's just a simple demo, but as you see, it's just 20 images. And now if I raise my right hand, it says number 2. And if I raise left hand, it always says number 3. And the interesting things is you can now use this result of the recognition very easily. So for example, oh, not this one. Here you see this is Scratch Cat. It's a mascot character of the Scratch. And here, like this, you can move this character by when received label 2, let me move it to right side like this, and I will duplicate if it received number 3, so -10, and now
nice. You got the cat is moving.
Yeah,
very cool.
This cat
So
is
this reminds
moving.
me of the old days when I was growing up. The little turtle you could program, which was like a little robot in the physical world, and you give it basic instructions. This is like a digital version of that using machine learning, which is really awesome.
And yeah, it's slow because it's label once every 1 second, but I can switch like this, label once every 2.2 seconds, and it's kind of fast like this.
That's cool. Yeah, you could see how you could make like a Pong game or something like this using this kind of interface.
Like I showed, it's very easy to program. So
wonderful.
Next, I will show another example. This is also use TensorFlow.js, and it's I use a PoseNet library. So here, let me hide these labels. Well, the good thing is it's an extension. It's like I said, it's a plugin. You can add both, like ML2 Scratch and PoseNet. You can recognize the position of the body parts, each body parts, like hands.
Very nice, very cool. So yeah, you can fully modularized, which is very
useful.
Yeah,
if I move here, the nose. So I will show interesting example. I will add some.
They're fully customizable with your own content. Essentially, you can animate whatever you like. Nice.
So I added a glasses image here, and I can do like forever move this image to my eyes position.
I see, yes.
So here, so the X is nose X is okay, and the Y position, so like left eye Y, and as you see, I wear glasses, so like this one. And you can. It's a little bit small, but you can.
You could tweak it to get the size correct with time, I'm sure.
Yeah. Like this one.
Perfect. There we go. You've got your new sunglasses.
Like this. So these are JavaScript extensions, Scratch extensions, and it's available if you search like ML2 Scratch. It's here, PoseNet. Also, it's on the GitHub. Recently, I found a face mesh to Scratch and face mesh and hand pose on TensorFlow.js blog, I created this extension also. Here is Scratch.
Very cool. And I must say, you've been very productive in converting our models to Scratch very fast. Every time we put a model up, I think within a number of days, you've already converted it to Scratch very, very quickly. So thank you for doing that. That's most kind.
And because it's very easy to code, now the community is using Scratch to create interesting projects. Let me show one example. Is this one is, well, the article is in Japanese, but you can see she created interesting project. It's called smart trash box, and it recognizes the object by it uses ML2 Scratch and combined with Lego.
Nice.
EV3. Also, Scratch has a EV3 extension, so you can control Lego by Scratch. So this smart box,
I wish I had this when I was a kid.
Yeah, and it recognizes the object. If it's a can, it's open the left box. If it's a bottle, it opens the right box. So as you see, it's very easy, but also it's very productive.
Awesome. Thank you very much for the demos. That's really cool. Feel free to answer any extra questions that might be coming from the community. And we shall move over to the next presenter as we have. Okay. Next up is Ben from Adobe, and he's actually created a really cool demo that allows kids to create or draw superhero costumes and then go and wear them. So over to you, Ben.
Hi, everybody. Yeah, so I'm Ben. I work at Adobe, like Jason just said. I'm a prototyper there. And this was a unique project for us because it was for a one-off museum experience. I want to show. Oh, I need to share my screen.
Nice.
All right. So I put together some quick visuals on what kind of this was. So this is a one-night event, and it was for if you're familiar with the Bay Area, there's a great museum in San Francisco called the DeYoung, and this is we every year they put on a fundraiser called the DeYoungsters event. It's an art party. It's for kids. It's, the ticket prices are kind of high because their parents will come in, they put on a great party for the families, and they'll fund the museum for the year. And so Adobe sponsors this. In addition to monetary sponsorship, we put together some sort of interactive exhibit for the kids to play around with when they're there. It's just a 3-hour thing. So this year, like Jason said, we had the idea of letting kids create superhero costumes and wearing them. I had not used TensorFlow.js yet. I had dabbled with something called OpenPose before, and it's a good project, but it's really hard to install. There's so many dependencies and stuff is always going wrong, but I thought we got to use this. It's going to be solid. But once we got it running on my MacBook, it was running at 2 frames per second. So we were all set to buy a hot top end gaming PC with a nice graphics card. And I'm like, okay, maybe we should let's just look at TensorFlow.js again, because I hadn't looked at it in a while. And I thought, okay, let's just see what it does, see if it meets our needs. And I was surprised, it really did. So what we ended up giving the kids, so this is one of our superhero templates. So we had one of our artists on our team draw templates, just stuff to color in. And this is like kind of a Wonder Woman-ish template. Obviously, it's not Wonder Woman because Wonder Woman's copyrighted. But so we give the kids these templates, and then they could draw. We'd set them on a table, let them draw all of them in, fill in what they want. These would eventually be sent to our scanning station once the kids were done. And I had a Node.js service that kind of chopped them up into different body parts based on some predefined masks we had. And then we set the kids in front of the camera. Here they are posing. And by the way, these are pre-approved kids because we're going to send out a press release soon on this. So we had to make sure the kids are good to show the public world. So these are Cheryl's kids, I believe. And so when the kids were in front of the camera, they could see themselves live posing on the screen wearing their costumes. And so here's one of our other artists, our designer, Kelly. She's manning the machine right now. And so what she does is she just like tells the kids to pose, and then she clicks a button to capture the image. And then once the image is captured, 4 of them, they'll get sent over to the printing station, and we'll get 4 pictures in a frame, all nicely printed out. And then here's an example of this is me and my wife posing. And just to zoom in a little bit. So obviously, this was a very quick project. I'm a perfectionist, and it kind of hurts me to show like some of the clothing not quite matching, but it was a quick project. And for what it was, the kids were really happy seeing their art on themselves. So it was pretty successful.
That's super cool. I love it. It really brings their imaginations to life as well, I presume, as well. I get super excited.
Totally. It was kind of a shame when the kids tried to color out of the lines because we had those preset masks, so it would ignore everything.
Yes.
But the multi-pose stuff was pretty nice because we just turned it on, figuring why not. But we had kids wearing the same costumes and posing as a family, so that's pretty cool. So I'm going to show a demo. I can't show the experience at the museum because it's a complete experience.
Yeah.
But before I do, I just wanted to share some of the technology I use that's not TensorFlow going into this. I am a huge web components nerd. I wrote a book. This is my book. I used web components in this project. And I also use something called lit-HTML from the Google Polymer team. It really helps you with declarative UI. It generates it helps you with HTML templates. I also use something from Adobe called Spectrum Web Components. So disclaimer, if you see any like pixels off in my demo, it's my fault. It's not Spectrum Web Components' fault. But Spectrum Web Components is for our design system, our internal design system. And it gives nice web components like buttons and inputs just so you can like put on your app ready-made. It's a great project. It's open source right now. And yeah, so those are the technologies that I use besides TensorFlow. Also, when I was developing this thing, since I can't show you the full museum experience with kids' artwork right now, I downloaded a paper doll Vincent Price off the internet, and this is what I developed with. So this is what I'm going to show you in my demo today. So yeah, I just cut this guy up and used him for the parts. So
awesome.
Let me switch it over to the demo. Let's see. So I just kind of named it Paper Doll because that's kind of what it is. So GitHub, it's on GitHub at Paper Doll. But if you want to click on, you can see some like caveats. But load up the demo. And so here I am. This is my live view, but I'm not going to show you my live view on this because it requires full body tracking. So I recorded a video of me dancing around my yard last night. Just to show off full body tracking.
Yeah, it's always hard to get the full body in webcam view when you're at home. Definitely.
So then I can just go show uploaded video instead. So here I am dancing around my yard. And so I'm gonna go and so for this demo, to share this link out, you can download a sample asset set. It's gonna give you a zip file. I already have that on my computer, so I'm just going to bring in some assets right here. And here are they, a bunch of different assets, all the body parts mixed together, and a manifest, a JSON-based manifest to, say the left arm goes with the left arm, and there's certain anchor points as well. So I'm going to mass select these and open them up. And instantly, I am Vincent Price. The head is a little bad. We didn't use the head in the actual experience. And you can see like down in the corner here, it's picking up some pose. Maybe it thinks there's a pose. So I'm going to turn off multi-pose. One of the things I did, I just, since this was, anything can go wrong in a 3-hour window at a setting you aren't familiar with. So I just put all the TensorFlow settings, the PoseNet settings in a UI right here, just to have that available. We actually never used them though. But yeah, so it's in terms of like anchor points and stuff. So I have an editor right here, so you can kind of see, okay, this left arm is mapped to the body part, the lower left arm, but I can adjust these anchor points. So like I'm going to move up the wrist a lot and make the arm super long. And I do the same for, let's do the same for the other one. So now I have super long arms, but the thing is, like, we can take photos now. Like, so here's a photo I just took. That's cool. One of the limitations, we had to use Electron for this because we were using a high res, like a 4K camera, and I couldn't. Like the Chrome won't let you put that on a download like that. That's too big of a blob. So that's why that's the only reason we use Electron for this.
Cool. And for those on the live stream, Electron is basically allows you to run JavaScript on native desktop apps, right?
Yes. We ran it on a OS X machine. And then we didn't have this at the, we thought we might have video at the site. We ended up not using it, but I had it in. I just uncommented the code for you guys right now. So I'm going to take a video. Whoops. It's taking the video right now. And then once that stops, it downloads. Unfortunately, it's WebM. That's the only way I know how to encode video for download. But here's a video clip of that we just took. So yeah, that's basically the demo. You can add whatever parts you want, really, and whatever ping assets you want that are transparent, and mess around with it yourself to put your own sample assets in. I might, in the future, I might go ahead and like, I'm trying to like make this map to a 3D environment right now. See how that goes. My 3D math is awful. So yeah, we'll see how it goes. But yeah, that's pretty much it. That's what I did. So
awesome. Thank you very much. That's a really cool demo. Thanks for showing us. And I put the links in the live stream so people can try it out as well. And of course, all of the links for all the demos today will be put into the description after the show has ended as well, in case you missed anything. So thank you very much.
Cool,
next up, we have Lizzie. Lizzie is from Twilio, and she's going to be talking a bit about sentiment analysis. Over to you, Lizzie.
Can you hear me? Okay. Hi, everyone. I'm Lizzie. I'm a developer based at Twilio, and I'm going to share some slides. I do a lot of demos, and I write for the blog. And I am by no means a big machine learning person, but I am getting better. And having a lot of fun with TensorFlow.js and the community. Okay.
Thank you.
Let me make this bigger. Okay. So I did text analysis using a pre-trained TensorFlow.js model that was trained on a set of 25,000 movie reviews from IMDb and given either a positive or negative sentiment label. This post will be using the CNN model architecture, but could also do an LSTM model architecture. Okay, so here at the top, I required TF.js, made my Twilio client because I wanted to analyze my text messages for the year. And I was like, did I have a good year? Did I have a good decade? And text messages even show that. But maybe not, but it was like still a fun project. And here in setup, this loops through text messages sent from someone's phone number, in this case, my own personal phone number as an environment variable, to my Twilio client. So to a series of Twilio phone numbers that I purchased throughout the year. And I set it for a certain time period, for all of 2019, until like made the blog post. You could, of course, edit the time to be like 2020. What day is it today? 4. You could also do April 4th. That's today. This year is going by very slowly. Okay. And the setup function returns an array of unique text messages. And you could also return not unique as well. Okay. And then Here, we fetch some metadata, which provides with the shape and type of the model, and we use node fetch to get that metadata, which is hosted at this remote URL to help train our model. Then we also need to equalize the sequence lengths, making each word sequence the same length. Padding is the default, and we need to convert the words to sequences of the word indices based on the metadata, and convert the strings of words to integers or vectorize them. Sequences longer than the size of the last dimension of the return tensor, metadata.maxLength, are truncated, and sequences shorter than it are padded at the start of the sequence. And then here is where we actually make a prediction for each message. And this accepts 3 parameters: one text message, the model loaded from the remote URL in the next function, and the metadata. In predict, the input text is first tokenized and trimmed with regex, regular expressions. Convert it to lowercase, remove punctuation, and just clean it. Next, those string words are converted to a sequence of word indices based on the metadata. Say a word is in the testing input, not in the training data or recognition vocabulary. This is called out of vocabulary, or OOB. And with this conversion, even if your word is OOB, like a misspelling or emoji, it can still be embedded as a vector or array of numbers, which is needed to be used by the machine learning model. And finally, the model predicts how positive a certain text message is. And we create a TensorFlow object with our sequences of word indices. And once that output data is retrieved and loosely downloaded from the GPU to the CPU, the synchronous data sync function, we need to explicitly manage memory and remove that tensor's memory with dispose before returning a decimal showing how positive the model thinks the text is. And here we have a helper function that compares each positivity score and determines whether that makes the text message positive, negative, or neutral. You can, of course, play around with the values.
Nice. And I'm just curious, like, what results have you got so far? Has it been working well?
Okay, I was going to get to that.
Yeah. Oh, okay. Sorry, my bad.
Getting into that. So here I tested it on a string. Hospitals are overfilling, and that returns roughly negative with a score of 0.42. However, if you try something like baseball is canceled, what will I do with my life now? Because like sports are canceled, there's no professional sports for obvious reasons. That should return positive, like very positive. So I think I also tried pandemic, and that also returned positive to neutral. I think it is interesting. Okay, kind of neutral, like 0.6535.
I see. Nice. So you could use this on a website to kind of filter out particularly negative comments or positive ones or whatever you want to do, right?
Yes. And going to leave this. You can see the blog post here on the Twilio blog.
Awesome. Yeah.
And I will drop the GitHub repo link in the chat as well.
Perfect. I've also submitted the link on the live stream chat as well for people who want to dive in deeper into the code and play with it in their own time as well. So, and I'll add it to the description as well after the live stream is over too.
Yes. So you can, of course, play around with, like, you don't need to use your Twilio messages for this. You can just test any string as we saw here. It also takes an array because I wanted to test different text messages throughout the year, and it would create the average of each prediction score. So we could do like pandemic and any input baseball is canceled. And you should get an average of those prediction scores. Okay.
Nice.
Stopping screen share.
Awesome. Thank you very much, Lizzie. And next up, we have Manish, who has been creating a prototype to count his reps when working out. Over to you, Manish.
Yep. Hey, folks. Hi, everybody. I'm Manish, and I'm a software developer from Velocity Technologies. This is a company in India. So, for me, this TensorFlow.js was extremely new, and I wasn't actually even aware that something like this exists. And I'm a web developer, so I mostly specialize in React.js. But I went to a UI conference and a bunch of folks introduced me to TensorFlow.js, and it got me very excited. So I started prototyping something with this. Let me share my screen. All right. So there is an application that I built using TensorFlow.js, and it's currently challenging to show how this works on a live stream. But I have a recorded demo as well. But let's quickly talk about this and how I got to building this. So I was doing some exercises at my home, like sit-ups, squats, and I wanted a counter for myself. The idea was there in my mind, but I did not know how to build this as a web developer, and I hadn't worked with TensorFlow or TensorFlow.js. But then I got introduced to TensorFlow.js and I started building this with body pics first.
I
So
see.
what we
Yeah.
have here is a bunch of models that you get with TensorFlow.js, and you can install them just like any node module that we have for our projects. So web developers are aware of how these dependencies work. And then I started with body pics and then quickly moved on to PostNet because PostNet is more suitable for my use case. So it gives me positions for the human body. Now, what I did was I injected an algorithm that I built for each frame that is processed. And what we have here is it mostly tracks your left eye, right eye, left shoulder position, and right shoulder position. So as a web developer, it wasn't something that I had thought I could do on a web browser. But when I got introduced to TensorFlow.js, and then I checked out body pics and the JSON that it gives me on each frame that is processed from the web camera, that got me thinking that this can definitely be done using inside a web browser. So yeah, then I built a small algorithm. Here, there's some to do here, like track hips to increase the accuracy of the squats counter. And then there's some future scope around this as well. Like I want to gamify this further in terms of adding social media integration into this because it's a web app, so that's easier to do compared to something.
It'd be cool to challenge your friends as well, like to kind of gamify it a little bit, and you can kind of see who can do the most, press ups or sit ups, whatever it is you're tracking, and you have the counters on each side of the screen or something, and connect people together to challenge each other in these hard times when we can't go outside right now.
Yeah, definitely. So there's this gamification that needs to be done here, but this works. And here's a demo that I can quickly play. This requires whole body tracking. So if I play it here, and I hope you can see the screen. Yeah. So it starts counting with you, and then it stores that in a database, so you know that how many you have done this year, how many you have done this month, and it just sort of gives you an idea of how it just sort of gamifies the experience for you. And this was something that I was able to build very quickly as a web developer, which I thought I couldn't. So building this was a cool experience. Couple of technologies that I use other than TensorFlow.js are a couple of tech that I used. Let me stop the video first. Right.
I love the voice as well. It's very very retro.
Yeah, so that's actually a single line of code here, thanks to Google Chrome. So speech synthesis is a API from HTML5 spec that allows us to just speak out a message. So this is one of the technologies I used. And then for the audio video capture, we have the HTML5 media APIs. So all of this is done in browser. And then obviously for persistence, you can use something like local storage or an API calculator or an API that you built on some service like AWS. So yeah, this was the quick demo from me. Yep.
Awesome, thank you very much. And I'm sure, well, people in the comments are saying, I'm sure your leg muscles are now massive after debugging this over time. So I'm sure you had a lot of working out to do whilst making this demo as well. Thank you very much. Next up, we have Rogerio, who from Amsterdam, I believe, who has created a cool demo that allows you to detect if you're touching your face or not in these viral times that we're living in. Over to you.
Hello, that is correct. Thank you very much. Yeah, so my name is Rogerio, and first a bit of background. A few weeks ago, we were still in the office, actually a month ago, while this all this crisis was starting. We were still not quarantined, but we were at the office, and the recommendation was to not shake hands and not touch your face, right? So there was this colleague of mine that he was remembering everyone to not touch their face, and every time somebody did, he said, "No, shame on you! You shouldn't do that." And it was a bit annoying, but it was actually very helpful. So I thought, hey, you know what? Maybe I can automate this guy actually. So I did a tool exactly to do that. Yeah. So let me show you first. Let me share my screen. So if I touch my face, I don't know if you can hear the loud noise.
We can hear the buzzer.
Yeah, so the computer reminds me that I shouldn't touch my face, and if I touch my nose or if I scratch my eye, anything like that, it will just buzz. And yeah, and you can even keep on the background, and while you're working, to keep buzzing at you, although it's very annoying. So I did it, but I don't really use that much because it's quite annoying. But so basically, I did that really quick, like it's nothing fancy, because I'm from a front-end development background, but I started studying machine learning like 3 years ago. Nice. So far, but I never did anything with TensorFlow.js. I was mostly doing on Python and such. And then I figured that since I had this idea and TensorFlow.js was there, maybe it's easy because I also remember another example. So this is actually mostly a fork from this other project, Teachable Keyboard, which does something similar. That like you move your head, just like Junya showed us with Scratch, that he taught the cat to move, left and right. So it's the same thing. It's basically the same principle. So I learned that I could do my demo in Scratch today. So that's cool. Yeah, I think what was interesting of that is that since I have the web here, I could actually make people train themselves, because I wanted to do this quickly. I didn't want to spend a lot of time finding images of people touching their faces and people not touching their faces, and then labeling and things like that.
That's very cool.
So yeah.
You could gamify this one as well, I think. I could see people, given we're all stuck at home right now, you could have like a little counter between you and your friends to see who has the least face touching in a given day whilst you're working from home. You could have
That's true. I never thought of this idea. Yeah. Yeah. I never thought of this idea, but yeah, it's a good idea. But yeah, so you can use these buttons to tell when the machine learning. For example, when I turn left, I think it's not okay. It's working, but if it were not working, I could adjust here when it's touching and when it's not touching. And I will just go a bit quick over the code. I think so. Most of the code is actually not the machine learning part, but actually the app itself. So I'd say the important part is this part. I don't know if you can see or if I have to make it bigger. I actually don't know how to make it bigger. Command plus not working.
We can roughly see things. If it is able to be made larger, I think you can press Control plus or Control scroll or something like this might make it larger if you're in Sublime.
Oh yeah.
Yeah.
Yeah, no, it's not working.
Oh, okay. I can roughly read what
Okay.
you're doing. If people go full screen, they should be able to see this. So, yeah.
Okay, editor font zooming. All right, I find a way. Let me zoom.
Ah, here we go. That's better. Yes. Lovely.
Slowly growing. All right, can you see better now?
Yes, we can see
okay.
that. Look, that's big enough.
Yeah. So I think the most important part is that is this. So we basically load the MobileNet here, and we also build a KNN classifier, which is K nearest neighbors. It's a simple classification algorithm. And in this case, we have two classes, touching and not touching. That's all. So I'll skip this part. But it, let me see where it's used. Okay, yeah, so there you go. So we have a loop that detects each frame rate of the video, right? And then we pass this image to this mobile network, the already pre-trained net, and we actually get the before the last layer. So neural networks, right? You have many layers. We don't want the result of MobileNet because I don't want to retrain MobileNet. So I just get all the processing, all the process that it does, and then I get this input, and I put this input as input to my KNN classifier. And then when I click this button, the touching or not touch button, I'm actually telling, if you receive this input from MobileNet, you have to consider it touching. Or if you receive this other input, you consider it not touching. So our KNN actually starts learning how to classify MobileNet outputs. So this is the transfer learning happening here. And that was it. And that's pretty much it. That's awesome. Nothing else to do. It's very...
I love that it keeps going off whilst you're talking as well. That's just brilliant. It's actually working as intended.
Every time I fix my glasses. now.
Thank you very much for showing us that one. And yes, we'll put the links, of course, in the description afterwards. Awesome.
Yeah, you're welcome.
So next up, we have Jimmy. And he is the creator of MLBlock, which is a visual editor for TensorFlow.js models. So over to Jimmy to tell us more.
Hi, everyone. My name is Jimmy. I'm a programmer from Thailand. I create MLBlock, which is a platform for the education of the machine learning. Okay, I will share my screen. The MLBlock is a machine learning platform that very easy to use when you start. You just create an input, something like an image, and you can have the pre-trained model like MobileNet, and you can create the output like labels. Okay, when we connect the three things together, we connect the input into the models and connect the model into the output. Okay, I can put image here. Okay, and the model will interpret that this is a picture of the laboratory.
Very nice. I love how it's all drag and droppable like this and just working in real time. Very nice.
Yes. This is a tiger. It's interpret like this. Okay, this is a penguin. Okay, we can change the models very easy. Like I have a euro here. Okay, I just disconnect this, and then I just connect to the euro. Okay, euro is loading. So when it's ready, it will show the.
Oh, very nice. And now you've got the bounding box as well, which is really cool.
And something like this. Okay, you can use the YOLO to locate the object, something like this. Or you can like complicate things like cars, something like this. Okay, I delete this. Okay, So the YOLO just detect the car and locate the car, something like this. Apart from the image, we can use like real-time input, like video captures. Okay, this is me. Okay, when I connect myself to the YOLO will detect the barrier happening, something like this. Okay, and I can also use pre-trained model, other pre-trained model like a postnet. We try to port as many as pre-trained model. Okay, this is a postnet. Okay, I delete the YOLO. This is.
That's really cool. And I guess we can take the outputs of this and link it with custom things, or is that something for the future? If we wanted to like take this PoseNet output and then I know maybe control a robot or something, could we like have our own server side calls and things like this at the end of this training pipeline?
Yep. We can create something fun, like we can create like another image input and put the input all together with this. Okay, so we have a two input here. So I just got the image like this, and I just show overlay. The overlay we show here.
Very nice.
I turn off the name. Okay, I put the right eye and left eye, something like this. So it's very easy for students to play with the pre-trained models. And after the student play with 3D models, pre-trained models, we can train transfer learning. Like
sure, yes.
I will use the transfer learning. I have a MobileNet feature extractor here. I connect the image to the MobileNet feature extractor. It will translate into the last neural network layers that we call the logits, which is the fingerprint of the image. So when I move this will change real time, and it will be the fingerprint of the image that MobileNet can recognize.
So you can train in real time in the browser to then recognize custom things, which is very nice. Yeah.
Yes. So I create the neural network here and connect the feature extractor from the MobileNet, and I create my own neural network classifiers here. Okay, I try to emulate like a gamepad here. Okay, I will train myself to be the gamepad. The gamepad has a 3-directional key that A, B, D, and E, and C is the idle position. So I train that when I'm here, I in the idle position. So I add my
adding samples for sitting. Yeah.
And this is my left key. Okay, I go add my image to the left.
Sure. Yeah.
And then I add to the right, something like this. Okay. And up is difficult. It's okay. I'm trying my best. Okay, and down.
And finally down, of course, as well. Yeah.
Okay, down is something like this. Okay. And then we train this neural network. So it's trained. Okay, successfully. Okay, I set up the time of the repeat time. The repeat training is at 400. So when finished train, it will create the neural network for you, something like this.
You've got the visualizations as well. That's very, very cool.
And you can use this as we create the output, something like this. Okay, and we connect to the output. So when I'm in this is a C. Okay, okay. Then I move is B, C.
Wow, that's awesome. You got like a real-time game controller using your face.
Yeah. Awesome. So I have a gamepad that using my face. Okay, so we can play the games here, snake game. We just connect it to the snake game. Okay, and we start. Okay, I go up.
This is very cool.
Go down. Something like that. So you can try it And the good part is I disconnect this first. Okay, so the game can play with. We plan to open source is very soon. Now is not on the GitHub yet, but let me clean the code for a while. We expected to open source this very soon.
Awesome. And just a personal question for myself as well. Like, how long did it take to create this? This seems to have like everything I've ever seen in TensorFlow.js in one place. So I'm just curious, how long have you spent making this so far?
I started this project in the, November last year. So
okay, so yeah, that's pretty fast actually. Very impressive.
I created it from the on top of the ML5 and some of the call directly to the TensorFlow.js, but mostly is through the ML5, so it's very easy.
I see. Okay, very cool. Well, thank you very much for the demo. And if any of the community want to get hacking with Jimmy, feel free to reach out to him after the show. I'll put all the people's links in the description for their Twitters and social media and all that fun stuff. Cool.
Okay.
Thank you, Jimmy. Okay, so let's see who is next. It's actually myself. So I'm going to go over to my Chrome view. I think that's working. Hopefully you can see. I've got a couple of demos that I've created and also one from the community who couldn't be with us today. So I'm going to show that on his behalf as well. All right, so let's get started. Now, the first thing I want to show you is the Disappearing People project. Some of you may have seen this over on Twitter, which I launched a few months ago. And before I get started, I'm going to make some room here in my room, live demos and all that. Now, what we're going to do is I need to disable my webcam because otherwise my browser can't get at it. So let's refresh the page here. Reloading the demo. All right, I can now enable my webcam. And in a second, you'll see hopefully my live view from the cam. Here we go. We're good. I'm going to scroll down. Okay, so at the top here, you can see the live webcam view. In the bottom, it's going to attempt to remove me from the scene as I start walking around. Okay, so let's try that out right now. I'm just going to start walking around. And now, as I come back in as well, I've completely disappeared, even though I'm standing in front of the webcam. Okay, now, to see the kind of effect this has on the environment, I'm going to get on the bed and show you, because I'm not just replacing with the background image when I walked out of frame, I'm actually recalculating the background in real time, so everything around me is actually updating. So I'm going to go onto the bed, and you should see the bed deform as I walk around on the bed. So let's try this. So you can see me walking around at the top, and as I go over the bed in the bottom, it's a little bit laggy and it's not quite perfect, but you can see the bed updating in almost real time as I'm walking around. And it gives you this kind of weird ghostly effect, as if there's a ghost in the room or something like this, which is quite cool. So this was actually created using body pics, which a few others have already been speaking about. And essentially, I'm calculating what pixels in the image belong to a body. And once I know where they are, I can remove them from the scene and replace them with the last known background. So one moment. What's going on here? Jimmy, can you mute your microphone? Sorry. So yeah, but essentially we remove the person from the scene in real time, and then all the pixels that are not body parts, I update to have a new last background image. So that is a basic algorithm that's going on there. For those of you who are interested in trying it out, I'm just going to paste the link into the live chat right now. That's the GitHub. Feel free to go clone the code and try it out in your own time. The next one is essentially real-time clothing size estimation. This is my latest prototype I've created. I've only got a video of this because it's kind of hard to do with my full body being in camera perfectly on the webcam. But here's a video recording showing you how that works. Let me just check my audio is working. One moment. Hello everyone, this is Jason. I'm a developer advocate for TensorFlow.js, and I'm here to show you my latest prototype that I built whilst I've been stuck at home. Essentially, I've made a system that uses body pics that allows you to measure your clothing size in real time in just a few seconds. So this makes it super easy to find what you want from different brands without having to touch the clothes themselves, given that everyone doesn't want to touch anything these days. And also it's much more simpler to find out your size when you don't usually know it for all the different brands out there anyway. So let's see how that goes. So let's see how that compares to what I really am. So I've got a tape measure, and we're going to go measure myself for the key parts we just saw and see how it compares. And you can see for my chest, we're getting 97, which is exactly what it predicted. And next up we have my waist measurement, which is just over 101 centimeters, which is actually pretty much bang on as well. And finally we've got my inside leg, which is really hard to show you, but basically we're going from just from the ankle to up near the top of the leg here, and you can see that that is around 65, so it's like 1 centimeter off in my prediction of 64, so once again, not too bad. As you can see, the results are pretty decent, and if you think you could use this in your project, feel free to give me a shout out on social media. Cool, so that's all from me, and then I'm just going to quickly show you one more from the community who couldn't be with us today. This is by Wen. I'll put his link in the in the YouTube chat right now. Essentially, this is a really cool particle effects kind of demo, which I need to refresh because it wasn't loaded before. 1 second. Basically, what it's going to try and do is going to find my face and then put my face into the cloud of the cloud of particles in real time. And it's kind of an artistic piece. It's kind of like a self-reflection piece. You can see the little human there staring at this big, ominous face in the distance there. And I can move my face around, come closer to the webcam, open my mouth and all that kind of stuff. And you can kind of see, this is really cool. This is like combining graphics and machine learning and just really cool UX to make this beautiful piece. So do check that out in the link I just sent into the YouTube live chat. And again, I'll put more links in the description after the show as well. All right, back over to the Hangout. We actually have Gant, who is our final presenter today. He has made lots of cool things, including a great online course. I'll let you talk about more. Thank you.
All right. Hey, everybody. Thank you so much for having me on here. It's fantastic to see so many people, especially the fact that I learned that I've combined all the knowledge and technology while I've been watching you talk. So if you notice now, when I touch my face, I get magic eyes and I talk amazing. So I appreciate everything that I've learned so far from you all today. No, I just want to I give a lot of talks. I create a lot of really cool stuff on machine learning, and especially with TensorFlow.js. So I'm actually going to present real quick. Is that blinking for y'all, or is that clear?
Hopefully that is definitely clear. Blinking.
Okay, even better. Oh, well, there you go. That's sorry, that's the alarm. I must have touched my face again. So this is a talk that I actually give quite often. It's a bunch of really crazy stuff in TensorFlow.js. It's a 30-minute, sometimes 45-minute talk. So I am not going to do exactly this talk real quick. What I want to do instead is take one of the case studies, show you that one, and then really help the community and those people who, I guess, are new to this kind of get connected. And so just real quick, who's this guy? Why should you listen to me? I work at a company where we actually do this stuff. I work in React Native all the time. I am actually a Google developer expert in web and machine learning. So you might notice that, or you might also notice sometimes these are my icons. I see these all the time. So if you see that, that's me as well. That's my branding. So I love machine learning. I think it's extremely exciting. If a lot of you have seen some cool stuff today, I've used it to actually make my friend into Nicolas Cage. That's a lot of fun. Things that were really cool. I want to say this was a 2018 demo that was really neat. We were doing this before TensorFlow.js, unfortunately, where we were applying makeup, and our developer Leon was up late at night. And unfortunately, we didn't have TensorFlow.js then, so we were doing it manually. It was with WebAssembly, but you can see Leon's here late at night applying makeup to himself. He had a good old time. We have tons and tons of really cool demos. I'd love to show you them all. One of the things I think that I really appreciate is that machine learning is like taking away difficult tasks and making them easy. So what I want to say is that one of the things we can do here is we can build some really cool stuff. And I would like to show you one of the things that we decided to buy in order to build. We came up with this idea that it is impossible for people to employ enough people to do content checking, and trust me, I do not trust myself to do anything but slideshows for this. So this will be 100% safe. Okay, I know some of you might be worried about the title there. So what we thought to ourselves was, what's something that can really help the community very easily? And I was like, you know what? People who hire companies, these big companies, they can't keep up. You know, they hire people to check the content of user uploaded stuff. And unfortunately, those jobs don't stay because people end up, they see too much terrible things and then they decide to leave. Privacy as well is important because, you know, you have people looking at perhaps messages between one another, and then consistency. So for a fantastic project that we decided to do as a company to try to help the community for free, we decided to make Not Safe for Work JS, where we can actually detect indecent content directly on the client's browser before it even leaves their machine. And what's great about this is if you have, let's say, a conference app, if someone sends someone else a message, it can flag it and say, look, you can unblur this if you like, but we're about 95% sure that you don't want to. And so I think this really helps people out. Now I'm going to give you a demo. The demo is an animated GIF because I'm not that brave. I would mess up and drag something improperly. So as you can see here, the categories are dragged over, and then you can see it set up. This is available on nsfwjs.com, and it blurs out the settings for you so you can't see anything as well. So this helps out a bit. Quite a few people have used this, and it helps out. Actually, the GitHub tickets are constantly being updated. And so much so that originally when I created this, it identified Jeff Goldblum improperly all the time. I'm not sure why. It got picked up on Twitter. It was hilarious. So one of the things that we had to do is we had to continuously improve the model. And unfortunately, Jeff Goldblum is gone. It actually detects him as neutral now. I disagree with that. I think he is a very, very handsome man, but it's hilarious. So this is just sort of the things that we've kind of done along the way. So is this still biased in some way? Yes, of course it is. Anybody who's new to this knows that there's a whole bunch of different versions of how this can work. And I can kind of go into some detail on how it's biased. It's actually biased the same way humans are. But since this is a short demo, I feel like you kind of got the idea. If you actually want to learn more about the project, contribute to it, use it. It's open source, MIT licensed. So now that everybody's kind of interested, I have lots of other really cool demos like showing like rock, paper, scissors that you train directly in your browser. But the last piece I want to say with here is that that's a really cool demo, but I want to see other people's demos. That's part of why I really enjoy being here. This is one of my favorite quotes: reimagining everything inspires science. And that quote came from Inspirabot. It was made by a bot. So I apply it to bots. That makes sense to me. So no human actually made that quote. So I will say we're constantly trying to help people. We help companies in consulting, and we help people in training. So I actually have a TensorFlow.js course. It's meant for people who have never done TensorFlow and TensorFlow.js and machine learning before. So if you're brand new to it, this is a great place. It's at academy.infinite.red. And then funny enough, I actually have a course, a Kickstarter coming out. I'll show you right here. This will be released next Tuesday, where I'll be doing some facial recognition AI. So this will be a course that's going to be backed hopefully next week. With that being said, if you want a multitude of resources, there's a coupon code. I usually keep that for my in-person talks. You can message me and I'll give that to you. So that's the talk coming soon. We have a free course that we give people. It actually has over 4,000 students now. And so one more thing I want to say is definitely follow the group that you see here with cool stuff. And also I run this Twitter account where I try to catch all the fun stuff, which is Fun Machine Learn. And has a really weird hashtag. Lots of people use it. I'm not sure why. And also, I just started at AIFYI.com, which is really cool. If any of you have an idea, message it to me. I will get it out to the masses. It has tons. It actually has thousands of subscribers already. I want to get the word out about TensorFlow.js and how cool this stuff is. I was a developer who was afraid of machine learning, and now you can't stop me from making cool stuff with AI and TensorFlow.js. And I want that same sort of experience for everybody else. So super thanks to the company that lets me kind of work on this stuff. Don't forget to follow me on Twitter. And that's it from me.
Thank you, Grant. That has completely blown me away. I was not expecting that. You kept that very quiet till the last minute there, so thank you very much. And I feel like I need to like burst out into singing right now or something like this. So thank you very much to Grant and all the presenters today. This was super cool to see everything that you've all been making, and I'm sure it's inspired many people who are watching on the live stream to take their first steps as well. Now, on the note of first steps, next up, I'm going to be trying to go through how you can get started with TFJS in the fastest ways possible. This is not going to be a deep dive like Grant's course, but in just minutes, everyone watching, no matter what your background, even if you can't code, will be able to make a machine learning model that recognizes something in their room, okay? We're going to do a live follow along with you all in just a few minutes. Now, after that, I'll go into how to use some of our existing more advanced pre-trained models that you saw other people using today. We've got some super easy to fork or clone code from Glitch or CodePen. So if you're familiar with JavaScript, that will help a lot. And then finally, at the end of the show, we'll stop the live stream and invite you to join the private hangout that currently all the presenters are on, for those of you who want to code and make something that you've been inspired by after seeing it today. So grab a coffee, take a bio break, and we'll see you back in about 15 minutes. I think everyone deserves a well-deserved break. And I do believe we reached over 100 people at our peak, so congratulations everyone for tuning in around the world. A very successful first show and tell. See you all in 15 minutes, and now over to the machine learning music once again. All right, welcome back. We're going to start kicking off. Please take your seats. Obviously I can't see you, but hopefully you're back at the computers. For those of you who are, please type lots of yeses in the live stream so I know that people are actually around right now. And then I can start kicking off for demos. Awesome, good stuff. Lots of yeses coming in. All right, so I'm going to send you a link in the live stream, and hopefully you will be able to load that on your computer. So there's a website called Teachable Machine, and we're going to start off with this. This is the easiest way to make your first machine learning model in JavaScript. This was created by a group at Google, a team at Google called Creative Lab, and we've been working with them closely to help get the models to be very performant in the browser. So once you've got that loaded, once again, please tell me that you've got it loaded in the live chat. You should see a screen that looks like what I have up right now. So please let me know when you have that, and then I shall continue. Cool, I see some loadeds coming in. Excellent. So as you can see, we've got 3 potential projects you can play with here. We've got images, audio, and pose. Today we're going to focus on image recognition. Obviously in your spare time afterwards, once it's the next day in some countries, you can try the audio and pose ones out yourself. So click on image and you should get a screen like this, as you can see. Now what this allows you to do is to have several classes on the left hand side where you can use your webcam, in this case for images, as input. So for class 1, let's just rename that to something meaningful. I'm going to say the word me here, because the first class I'm going to try and detect is myself. And if you do the same, you can detect yourself as well. So just call it me for the first class. And then in class 2, look around you in your room right now and find an object you'd like to classify. I'm going to choose a can because I've got this drink can here. It is available to me on my desk right now. So find something in your room. I'll give you 5 minutes just to go find an object in your room somewhere. And let me know when you've got an object ready to use. I'll give you a few minutes to do that. Back to the music for a second. All right. So hopefully, oh, 1 second. Hopefully you've all got an object that you're willing to use in this demo. So let's go ahead and start training things. So the first thing you need to do is go to the first class, so for the one that says me at the top, click on webcam, and you might be asked to enable access to your web camera at this point. Say yes, allow, load, good. So you should see a view like this, and you can see a live preview of yourself. Now, click the hold to record button and move your head around a little bit to get different angles of your head, just to see what you look like at different angles. That gives a machine learning the best chance to learn what you actually are. So you can see I've got 39 image samples in this example here, okay? Now go ahead to the bottom and click on webcam for the second class, and then take your object of choice and hold it fairly close to the webcam like this, and then repeat this process one more time. Hold to record, move it around this frame until you've got about a similar number of images for class 2. So you can see I've got 40 images over here. Everyone with me so far? Yes? Please let me know in the YouTube live stream if you've managed to record some sample images. I think people are still busy. Oh, a few people coming in now with yeses. Excellent. Great. So now what you need to do is click on Train Model in this middle section here. And you'll see it says training. Do not close your browser. Do not move anything else. Just let it be for a few minutes. And it will take a little while to load up the model. But you can see it then trains in real time. And when it's finished training, it will show you this preview on the right-hand side. Okay? And essentially, you can see now that it's predicting live from the webcam the class it thinks it's seeing. So obviously, you can see down below here, it says me with 100% confidence, which is correct. This is what the class 1 was. Now, if I put my can up here, it switches to can as the prediction. If I move it away, it's me. Can, me, me. And it's really fast. It works in real time. So go ahead and play that yourself now and see if you can recognize the objects that you chose in your room. And let me know any feedback you might have from that experience in the YouTube live chat. So there's a question around what's happening here on the back end in order to be able to do this. So what we're doing here is we're essentially trying to retrain an existing machine learning model to be able to recognize new objects. So I believe Teachable Machine is using something called ImageNet. ImageNet is a model that's open sourced already by the TensorFlow.js team. It's available on GitHub. I'll be going through all of these in just a second, actually. And that can recognize many hundreds of different objects already. Now, of course, it doesn't know what JSON looks like, and it doesn't know what a can looks like potentially. So what we're doing is we're retraining the top layers or adding our own layers to then be able to take the training data we've got from our webcam live in the web browser and then do the retraining only on those upper layers of the model. And that allows us to train it really fast. As you saw, it just took a few seconds to retrain rather than having to retrain the whole model itself. And with that data, we can then predict for the things that we desire, whether or not, in this case, it's me or a can. Cool, I see people saying that they've got it working. Excellent. So this is the simplest way you can get started with machine learning in the web browser. And if you create something useful here, you can also add other classes. You can see on the left-hand side, you can click on Add Class to add more than 2 objects to recognize. You can then export the model, clicking Export Model in the top right, and that will export a JSON file that contains all the trained weights for the machine learning model that you can then use in TensorFlow.js on any other website you so desire. So maybe you want to take something like this and produce hotdogornot.com. You can actually then take this and digest it on another site with a nice UX and a nice example for people to actually use in the real world. Cool, so that is Teachable Machine. Now, next up, I want to talk to you a little bit about what models we have available in TensorFlow.js that are pre-trained. So we just heard that this used ImageNet. So let's look at the other models we have available. So if you go to the TensorFlow.js website, this is tensorflow.org/js. I'm just going to put this into the live chat right now. You can see you come to our main website here for JavaScript TensorFlow Machine Learning. And you just click on the See Models button in the middle there. And this will take you to this lovely page, which I need to update. This does not have all the models on it right now. So if you click on any one of these models, just click on Object Detection, for example, it will take you to the GitHub page. Whoops. The GitHub page with all the details that you could ever want about how to use this model we've created. Now there's a lot of details here, you can read this in your own time, but essentially if you click on TFJS models at the top here, you can see all the ones that we have available. So basically I'm going to go through some of my favorites right now in just a second. I see some questions are coming in, so let me just check the live chat as well, 1 second. Yes, so some people have noticed that in the previous demo for Teachable Machine, some other things might also be classified as the second object. So maybe you put your hand in the frame and it then thinks it's a can because it looks a little red or something like this. So in order to train any machine learning model, it all comes down to the training data. Now we spent literally 30 seconds making those models just a second ago, and we've had like 40 images of each thing. In order to prevent errors occurring in the real world, you're going to need to have much more training data than that. You need to have, you know, images of your hand and other things just to show other parts of your body that might pop into the scene that you're trying to classify to tell it that that's actually part of your body and not the can. So it just takes more processing power and more time to essentially come up with a more robust model. And this is how essentially you need to be mindful of biases, because even though you think you're training things and it works for you, if someone from a different country is trying to use your model, it might not work for them if they've got a different colored can or something like this. So in the case of my can, maybe you need to show cans that are green, red, blue, so then the model will realize that the color is not important, it's actually the shape that's important. Unless you show it all the different types of cans that exist, it's never going to realize that, okay? So just a bit of background there for you all. So over to the TF.js models. So let's go through some of my favorites here. Now the first one I'd like to call out is body pics. This is how I created the invisible person demo that you saw earlier. This essentially allows you to pass an image and it will give to you all the pixels in that image that belong to a body, essentially. And you can do that with whatever you want. You can either overlay clothes like we saw before, or you can choose to remove the person from the frame. You can blur the background, make some special effects, whatever you so desire. It's really up to you and your creativity what you're going to make with that. Next up is Cocoa SSD. This is actually a fancy name for object detection. It describes the model architecture that's being used for it to work, but this is just object detection. And what's cool about object detection is that it gives you the bounding box, that little rectangle, to show you where in the image the object is found, okay? So potentially very useful if you want to recognize certain things in the image and show where they are in the image. Next up is face mesh. This allows you to recognize hundreds of facial landmarks in real time. Facial landmarks are just key parts of the face, and I think you can recognize over 400 of them. So for that, when you've got that level of granularity, you might be able to do something like an AR face mask or something like this, whatever you say desire. We saw the demos earlier already making use of this technology in the browser to shoot lasers from the eyes and all this kind of fun stuff. This is basically how they did it. They're using face mesh to power that. Similarly, we have hand pose, which allows you to do the same thing but for your hands. It can track, I think, 21 points on the hand, so you can kind of see where the skeleton of the hand is, and you can then maybe use that to do some kind of gesture recognition or something like this. We've also got a KNN classifier. This is just K nearest neighbor. So if you've got numerical data and you're imagine you plotted that on the graph, you could then essentially find for a new point which cluster it probably belongs to from the things you've already labeled. So that can be useful for numerical data especially. We also have MobileNet. Now MobileNet is image recognition. And the key difference between image recognition and object recognition is that image recognition will tell you if something exists in an image, so a true or false value, like yes it exists or no it doesn't, but it won't tell you where in the image it is, okay? And that's a key difference here. And the other thing to be wary of is that it will only give you a list of probabilities for all the things it thinks might be in the image. So unlike Cocoa SSD, which can detect multiple things at the same time and label them all individually, MobileNet won't be able to do that. It will just give you a list of probabilities that it thinks are the best matches for what it sees. Now, the benefit to MobileNet, of course, is that it's faster to run because it's not having to search the whole image for all the different items that might also be existing. So it's a trade-off between performance and the ability to draw a box around it, essentially. And it's over to you to decide what is best to use in those use cases. Next up, we have PoseNet. PoseNet allows you to detect the skeleton of your body, essentially, which allows you to then overlay things or detect a gesture with your body, that kind of stuff. It's super performant as well, so do check that out. And then finally here we have the Q&A model, which is the BERT natural language processing model that now runs in the browser. This one allows you to ask a question with a given piece of text, and essentially it will try and find the answer in that piece of text. It's like a it's like a command find with steroids, essentially. It can do much more advanced stuff than a control F can do. Have a read on that one if you're interested in natural language processing. And at the end, we've got some more natural language processing stuff, and also the ability to recognize speech commands, for example, so audio recognition in the browser. One thing to bear in mind about the speech commands example is that it's going to be short form speech. We're not talking dictating whole sentences. It's more like 2-second, 3-second clips of audio. That's what it's best suited for. The other things might need more memory, and that's something we need to look into in the future in the web browser. So that's just a quick overview of some of the models we have available. And this page is updating all the time. So do check back regularly and check the TensorFlow blog for our latest announcements, and of course my Twitter as well. So we're going to actually look at Cocoa SSD today to show you how I've coded this up. And to do that, I have example code waiting for you over in CodePen or on Glitch. Now, these are both websites you can use that allow you to code JavaScript in the web browser, so you don't even need to install anything for a text editor on your machine. You can do everything in the web browser. So I'm just going to post these links to you right now in the live chat. There's codepen.io, and here is glitch.com. There you go. Now, on CodePen, to find the TensorFlow.js goodies, we actually have a dedicated topic. So if you click on the left-hand side, there's topics, and you'll see all the different types of JavaScript fun that is available for you to get started with. And here we've got TensorFlow.js. So if you click on TensorFlow.js, you'll see that we've got a bunch of demos that are ready to go for you. And these are just a little bit easier to use than reading the raw GitHub README files. And this is going to be working out of the box. And you can click on any one of these. We're going to be using the object detection, the second one down here. And for those of you on glitch.com, if you're on Glitch, simply to find us, go TensorFlow.js, and you'll see our team page come up here in the search box. Click on the search box, and then scroll down, and you'll see all the projects that we have featured. This is exactly the same as what's on CodePen, just replicated on the glitch.com environment, as some people prefer to use glitch.com. And today, in fact, I'm going to be doing it in Glitch as I've got the window still open. So essentially, click on the TensorFlow.js object detection. And for those of you who are not on that yet, I'll send you the link in just a second. When you get to this intro page, click on remix this at the bottom right-hand side. And what the remix will do is clone this to your own repository within glitch.com, which you can then edit the code and hack and do what you like with, essentially. So just click that button and hit remix. As I own this project, I'm going to go to edit because I don't want to remix this myself. This is the code I've already written. So let's go ahead and click edit. So once you've remixed or you clicked edit, you'll be able to come to this page where you can see all the files. On the left-hand side, you can see you've got the index.html, the script.js, and the style sheets, the CSS file, okay? So what we can also do at this point is at the top here, we can click on show and next to code. This is going to show the live preview of the code on the right-hand side. So anything you edit on the left-hand side is going to appear on the right. Now I'm just going to pause for a minute to let everyone get started and also answer a few more questions that I see popping up in the live chat. So feel free to go to this example here, which I'm going to paste in the live chat as well, and open that up on your screen. And once again, tell me when you're ready to get started. I'll give everyone a few minutes to open either CodePen or Glitch on their screen. And in the meantime, I'm going to check the questions on the live stream. One moment. So someone's asking about the transfer learning earlier. Do the classes not get saved? Essentially, if you wanted to save what you have created on the Teachable Machine site, you need to click on the Export JSON, Export Model button at the top right, and that would then allow you to save the model that you trained to then use on your own website. And there's examples online on how you can load the saved model in TensorFlow.js to then use on your own website. Cool. So for those of you who are trying to load up this website, can you confirm for me in the live chat if you have my current view essentially loaded? I see a few people anonymous faces here in the top left. So I assume some of you are in here already. Just feel free to let me know if you're ready to start this in the live chat. That would be great. So yes, there's a quick question between raw TF models and converted models. So all the ones you're seeing today are like raw models that are working in TF.js. We've actually designed these models to be working in the JavaScript environment. There is a way to convert Python models into TensorFlow.js format. Now this depends on the operations you've used in Python. Some things can be converted, some things cannot be. TensorFlow.js supports a few hundred of the TensorFlow ops, and if the model was using those ops, then it is convertible. And if you use some other op, some lesser known op, then maybe it won't be convertible. However, on Node.js, all Python models can be run in Node.js directly without conversion, which is pretty cool. So if you're working on the server-side environment with Node, you actually get full support, as it's actually talking to the same C++ API behind the scenes on the server side. So Node is as performant as Python, if not better, because of the just-in-time compiler. It will actually optimize your JavaScript on the fly as you're running the code. So if you have a lot of pre-processing or post-processing code in JavaScript, that will run faster than Python in a lot of use cases. In fact, one of the community, there's a company called Hugging Face that do natural language processing examples, and they recently released on their GitHub, they got a 2 times performance increase by using Node.js over Python, which is pretty cool. Cool. I think everyone's got it loaded, so I'm going to go ahead now and just walk you through this code so you can get familiar with it. And that will allow you to then start hacking in our hacking session after this live stream is over. So listen up and check out my screen for now. So first of all, we have our index.html. This is pretty much boilerplate HTML code. There's nothing too fancy going on here. We've got our head tags here. We can see that we've imported the style sheet on line 11. We've got the body tag that has the content of the web page. All this stuff you can see on the right-hand side being rendered is simply written here on the left-hand side. We have our 2 images, the cats and the dogs here. And we've got our second demo, which is the live view demo. I'm going to show you how to use this with a webcam as well. So in this demo, I'm just going to show you it working. You can click on any of these images, and you can see in real time, it classifies the image and draws the bounding box around it. And at the same time, I can also click Enable Webcam, and you can see me live in the web browser, recognized as a person with around 80% confidence, which is reassuring. So you can see, I'm going to show you how to do both of these 2 things in just a second. So on the left-hand side, let's continue looking at the left-hand side code here. At the bottom, we have 2 JavaScript imports. The first one is for the TensorFlow.js library, and the second one is for the Cocoa SSD model that we just spoke about. So you can import those 2 lines of code into any website, and that will give you the power to use TensorFlow.js models instantaneously, which is really cool. And then finally, at the very bottom here, we have our script tag to load our script.js, which we'll now go into. And just quickly, the CSS here is just very basic CSS, so it looks somewhat pretty when I show you this demo. You can change this as you see fit. This is nothing important here. So over to the script.js. Any questions on the HTML first, actually? Before I get started, any questions on that HTML I've just shown you? I guess people are enjoying fiddling around already. If anyone can just let me know if they're cool to move on. Okay, perfect, thank you. Good, so let's look at the JavaScript now. So this is where you need to pay a little bit more attention, so just pause what you're doing. If you're trying to hack already, let me just walk this through with you to avoid having to repeat myself later. So at the top here, we have a bunch of constant variables. Essentially, these are just grabbing references to the HTML elements that we saw in the earlier code for easy access. We then have 2 global variables, one called model has loaded, which is set to false initially, and that allows us to track if the model is loaded or not. And then we have a global variable for the model itself, which will be populated when the model has loaded. So the next line of code actually loads the model. You can see here, all we have to do is call cocoassd.load. Now, for different models, if you decide to use body pics or something else that we demoed earlier, this will be a different name and it might have a different function to call. Check the GitHub documentation to see what the function name is, but it's going to be much the same principle. Now this function returns a promise, which is why we're using the .then statement. What this allows to happen is for some asynchronous function to go and do its thing, and then when it's ready to call a callback function. So we specify the callback function in the then statement here, and you can see here it passes us the loaded model. And with that loaded model, I simply assign it to the global variable and set model has loaded to true. So then other parts of my code are aware that the model has been loaded, and I can do other things at that point. And then finally, you can see here, I simply change the CSS styles to remove the blurring I had initially to show that the demo is now ready to be interacted with. And just to show what I mean by that, if I refresh the page, you see it's all gray here right now. And when the model is loaded, give it a few seconds, it comes into color. So that's how I did that. Just one CSS class. I just simply had an invisible state, which makes it the opacity set to 0.7 or something like this. And then I just remove that class, and you can see the cats are now in full color. All right, so the first part of this code, I'm going to show you how we can essentially classify a single image, okay? Now, what I do here is I am getting a reference to all the images that should be clickable in our web page. Obviously, you don't want to click on an image that's not intended to be classified. So here, I just want the dog and the cat image to be classified. And I've given in the HTML this special class called classify on click. So if you look at the HTML code over here, you can see I've wrapped the image in a div, and that div has the class classify on click. So in this JavaScript, we're just grabbing all the references to those classify on click elements. Now we have a for loop that will go through all of those elements that were found, and for each element that we found with that class, we simply are adding a click handler, an event listener, that when it is clicked, we're going to call a function called handle click. Now, the function for this is just below. Here's my handle click function. And as you can see, we have the event passed as the parameter. And the first thing we check is if the model has not loaded, we're going to return straight away and not do anything else, because if the model is not ready yet, there's no point trying to use it because you're going to get an error. So we just return and bail out the function straight away. Now, oh, 1 second, there's a question in the live chat. The images are still grey, not loading. Oh, yes. So if you have a very dodgy internet connection, the model might take a little time to load. Try refreshing the web page if you're having issues, or try on glitch.com if you're having issues on CodePen. Once again, I'll just quickly paste this link for people who might be having issues on CodePen. Here is the glitch version for you as well. Cool. So continuing with this example, so you can see the next line allows me to actually use the model. So there's this model.detect method. And once again, different machine learning models might have a different function you need to call. So check the GitHub documentation. But here it's called .detect for the Cocoa SSD model. And all we do is we pass to this function call an image-like object. And what that means, an image-like object can be something like an image, the HTML5 canvas object, or even a video object which contains the live stream of your webcam, for example. And basically, this has been written by the TensorFlow.js team already to be super friendly for you to get started. So it's very easy to pass it any image you desire. And once again, we have a promise. So there's this .then to be called, which once again accepts a function that takes the predictions as an argument. So once we detect something, it's going to pass back the predictions that it found for the image we're trying to classify. So all we do then is we loop through the available predictions that came back from that detect method, and all I'm doing in this chunk of code is constructing some HTML elements and setting the text to be showing the confidence and setting the style to be the right X and Y values that are shown in this prediction object that comes back. Now, if you're curious what is in that predictions object, I strongly recommend you just simply write console.log just above and put predictions there, like so. And if I open my console right now, oh, running out of screen space here, 1 second. Let's open the console, remove these errors here. So now you can see if I click on the dog here, you can see I've console.log the results. This is the predictions object that is coming back in this function just here that I'm highlighting right now, okay? So you can expand this and kind of see the properties that come back in this predictions object. And we've got this thing contained within an array. So we've found one object, so you can see there's one item in this array. And then within there, we've got this thing called bbox, which is the bounding box. So this gives you the x, y, width and height, I believe, for the bounding box coordinates that you need to render the paragraph tag with later on. And you can also see the class that was predicted under the .class property here, which in this case is dog. And then finally, there's the score property that shows you the confidence. So this is saying it's 90% confident, 0.9 represents 90% confidence that it is sure that it saw a dog in that case. Okay, cool. So let's just refresh that page again and continue on our descriptions here. Whoops, refresh. What's going on here? There we go. Good. So that's basically all you need in order to classify an image. Okay, and if that is the minimum code in about 100 lines, well, 94 to be precise. And I've done a lot of documentation here as well, like nice, helpful comments. It's probably much less code than this. With just that code, you can classify any image you like. Now, one thing to note is that you'll notice in the HTML here, for the images that I loaded, you can see here that I have this special attribute called cross-origin equals anonymous. Now, any image you're trying to classify in JavaScript needs to have the right headers set from the server. If you're using glitch.com, it will set the headers for you, and just adding this attribute will then allow JavaScript to access it. If you get an error in your console saying something like canvas is tainted due to cross-origin or cause issues, that's because you haven't set this attribute correctly. So make sure you do set this attribute here if you're using images in the web browser from a different domain or something else. Top tip. All right. Any questions on that so far before I move on to the second part of the demo, which will combine this with a webcam instead of just a single image? Feel free to shout out in the live chat if you have any thoughts or questions on that so far, or if you're happy, if that made sense, also let me know. Always good to know. Yes, I know, cause can be annoying, but it's there for good reason, to prevent security issues cropping up. But yes, if you're running this on your own web server, you'll need to set the headers for the assets that you're delivering to JavaScript to have the correct headers. And there's plenty of tutorials online about how to set up cause correctly. But for those of you who don't want to deal with that right now, just use something like Glitch, and you can upload your own assets under this assets folder, as you can see here. This is where I'm hosting all my images for this demo. You can just drag and drop files here, and it will set the headers correctly for us to use on our demos on glitch.com, which is super useful, so you don't have to deal with cause. Where did you get the parameter event? Oh yes, great question. So let me just go back to that. Where did I have the event code? Oh yes, on line 61. So I've got this handle click, and I've got the parameter event. Now, when you attach an event listener to any elements in the HTML DOM, essentially, when you have a click event, for example, it's going to pass the event object automatically to the function that you specify in the second parameter. Now you can call it event, you can call it E, you can call it whatever you like. I chose to call it event because it makes more sense. It's the event object that's being passed. And that allows me in line 70 to then use event.target, which basically gets the reference of the HTML element that was actually clicked to be passed to our model detection method. If I didn't do that, I'd have to manually figure out what image was clicked myself and then get a reference to it and pass it to the model.detect. So this is just a shorthand for doing that, essentially. Any other questions before I continue to the webcam version? Cool. Glad that makes sense. All right, I'm going to continue to the next part. Once again, I'll give you all time to start hacking with this after this session is over. So feel free to just check the next bit out. So demo 2, this essentially is mostly, this predict webcam code contains similar code to what we saw before, with some extra fluff around it to be able to get access to the webcam. So here you can see we're checking if we can access the Get User Media API. Now this is an API that's available in JavaScript in most of the modern web browsers that allows you to access the webcam. And all we're doing here is we're checking if the current browser we're in, navigator.mediadevices.getUserMedia exists. And if so, we can then know if the browser supports a webcam or not. If it doesn't, we can show an error message or something like this. I'll leave that as a fun piece of code for you to write, but this just is a useful function to detect if a webcam is supported. Now, if the webcam is supported, if you jump down at the very bottom here, you can see me using this function on line 178. I'm just simply calling that function I just showed you, has get user media, and that's going to return a Boolean value, true or false. Now, if it returns true, I'm going to get a reference to the webcam button. So here you can see I've got a little button called enable webcam. This is me grabbing a reference to it, document.getElement.id webcam button. That's the ID of the button. And I'm simply then adding a click handler again for this button. So when we click the button, it's going to execute this function called enable cam. Okay. Otherwise, we're going to say that get user media is not supported by your web browser and warn the user that they got a very old web browser. So essentially, if enable cam is called, we're going to go to this function just above. This is the enable cam function. You can see me highlighting it right now. And just like before, because this is responding to a click event, the event itself is passed as the first parameter of this function call. So I've once again called it event. And you can see me on line 156, check if the model has loaded. So if the model hasn't loaded, I return instantly to avoid trying to process anything when the model is not ready to process. Otherwise, I continue. Now, just like before, I unhide the button if it's ready to rock, and I then set up some properties that allow you to customize what parts of the webcam you want access to. In this case, this is just a JavaScript object, as you can see with the curly brackets, and we've got a parameter called video that's set to true. So this is trying to force the video part of the webcam, because on the webcam you can also get the microphone and anything else that might be attached to it. So right now we just care about the video and the mic, but for this demo we only want the video. So I've just set video to true. And then just below this is where the magic happens. There's a special API call you can do in JavaScript called navigator.mediadevices.getUserMedia. You pass the constraints object that we just defined above, which specifies you want the video to be showing. And then once again, this returns a promise, hence we have to use the then method, which passes the result, the stream object, to a function of our choosing. Now, I've just got an inline function here. You could have a separate one if you so desired. And this just takes the stream that comes back. And I set that stream to be the source of a HTML5 video object. So this video variable here is simply a reference to the video object in my HTML code that you can see over here. Where has it got to? Let's see, here. So I've got a video object with an ID of webcam, as you can see here in the HTML. And at the very top of my JavaScript, you can see that I got a reference to that and called it video on the very first line. And then down here, all we're doing is we are, where's it gone? Where was I? Here we go. All we're doing is we're setting the stream to be the source object property of that video, okay? And then once we have done that, we add one more event listener to detect when the webcam stream has loaded. Because before then, you're just going to get black pixels, essentially. It's going to be useless to you. So you want to wait until the webcam is actually ready and streaming data into your web browser. And when it's ready, it's going to call this function called predict webcam. And predict webcam is this main loop that we have going on right here. So most of this code in predict webcam is exactly the same as what you saw before for a single image. The only difference is that at the very end, we are using request animation frame to call predict webcam again and again and again. So as the webcam changes its frames, we're able to refresh the predictions with the latest data, okay? And that's how we're able to redraw things in real time. And we're just simply overwriting the previous text that we had with the new predictions every time we call this function. And for those of you who don't know, request animation frame is a super useful API that allows you to ask the browser to tell you when it's ready to when it's ready to take more data or to do more code execution. If you don't do that and you run this code on maybe a mobile device or something that's really low powered, you might overwhelm the mobile device. You might assume it can run at 60 frames a second, and if you just recall this function again and again and again, it would have no chance to breathe to do the other things that browsers need to do, like re-render the screen and do other things. So in that situation, it's always best to use request animation frame, and what that will do is it will call the function you specify when it's ready to do the next job. And that will allow you to have much better quality, less janky demos when you're creating them. And that's basically it. That is all the code that you need to get started. And with that, you have the power to use pretty much any of the models that I showed you earlier with images and with a webcam. So that basically concludes what I'm going to show you on the live stream. We will have some time to essentially work through any demos you're trying to create, or just start hacking together in a Google Hangout, which is separate to the YouTube live stream. I'll send the link to that in just a second. So just give me a few minutes to set that up, and we shall then continue with that. One moment. Okay, I got this the Hangout ready. So before I do that, I just want to say thank you once again for joining the first ever TensorFlow.js community show and tell. I hope you had a lot of fun. And of course, if you have feedback or want to see more of these kinds of things, do let me know over on Twitter or LinkedIn. Just search my name, Jason Mays, M-A-Y-E-S, or whatever social channel you're actually using. And if you use the hashtag MadeWithTFJS for anything you do create, that will enable me and my team to find those demos and hopefully invite you to future show and tells as well. So thank you for watching, and see you next time. And for those of you who are staying on, I'm going to send the Hangout link to join so we can all hack together offline in a private Hangout. So check the YouTube live chat right now for that. Here you go. This is the Hangout. Feel free to come and join that right now, and we'll continue over there, and you can share your screen and all that fun stuff, and I can help you out with anything for another little bit of time. So see you over there. Thank you very much.